be using. Based on it, it may be a simple linear regression model or it may be a multiple linear regression model. So in order to represent the linear relationship, we can use the mathematical representation as y equal to bx plus a. Already that concepts already explained by explained in the previous section by the Mr. K. Vignesh Aranan sir. Anyway, I will just recap it and go through it very fast. Okay. So in order to represent the equation, in order to represent the linear relationship between the two variables, right? So we have the equation as y is equal to bx plus a, where u is the intercept of constant and b is the slope. Okay, and what about the x and y? That x and y are the data features. Here, the y is the dependent variable and x is the independent variable. Okay, so based on the variation of proportion of the variation of x, we will get the result as y. That's the reason we can say y is a dependent variable and x is the dependent variable. So here we have a control only on the intercept as well as the slope, that is a as well as the b. That area only we have the control. We can able to vary it. Based on the variation, we can able to change the proportion of the x value. Based on the x value change, we can able to get the dependent variable output or target variable output. So based on it, we can able to draw the multiple straight line depending upon the slope and intercept. We have to give most optimal value for intercept and slope here. Okay, so it fits multiple line on the data points and returns a line that result in the least error. We have to get the least error. So you are going to draw the lines means most of the data that has to be fit on the line means that time we can say that model is good for prediction. Okay, so that's the thing. I had already gathered some information from the previous session, and based on the independent variable, one or more independent variable is going to be changed. Either it may be increase or decrease means, right? Based on it, surely the dependent variable is either going to become increase or decrease. Suppose the independent variable goes up, at the same time the dependent variable is also going up means that type of linear relationship is here called as the positive linear relationship. Okay, and similarly, independent variable goes up, but the dependent variable is going to goes down means on that time we can say that is the negative linear relationship. Okay, already he has Vignesh Aranan has explained about the least square method. With the help of that least square error method only, he evaluated the linear regression model with some case study. Okay, already he has explained what he mean by the least square method. It is a value of the a and b for the best fit line. Just we are going to choose the a and b value, that is intercept and slope value. We are going to be chosen correctly means the most of the points in the data set, feature points are going to be set in the lines means that values are here called as the that values. We are going to be minimize that square distance from each data point to the lines means that time I will get the least square error value is going to become low. But anyway, if you are going to implement linear regression model by using the Python with the help of the scikit-learn, you don't worry about how the equation is working during the implementation. Okay, right. But anyway, you should know some mathematical concept of how it is working. If you want to create a new model from the or modified version of the linear regression model, or you can go for somewhat variation in the linear regression model means on that time surely you know how the equation is working. Otherwise, suppose if you are going to simply use the linear regression model for particular application for predicting something means there is no need to worry about how the equation is working. Right. Next, we talk about the multiple linear regression. Right. What about the multiple linear regression? What about the linear regression, multiple linear regression. Okay, whatever the concept we had studied in the previous case, that is a simple linear regression model. Okay, where we have taken y is a one independent variable, only one dependent variable we have been taken. Okay, so that's the reason we can say that is a single linear regression model. Okay, that we are going to repeat the above concept for more than two variables here called as the multiple linear regression model. For example, if you are going to predict the sales revenue, which is based on the advertisement we have spent for the media like TV, radio, newspaper. Okay, so we are going to be predicting like this. Due to spend the advertisement in the TV, how much sales revenue you have got it, or based on the advertisement money we have spent for TV as well as radio, how much sales revenue have been improved. That is the way you are going to be predicted. That is more than two variable you are going to be used for predicting something, means that type of linear regression model is here called as the multiple linear regression model. Okay, so here always we are using the word dependent variable. That is nothing, it's a target variable. It is dependent on the several independent variable here. So the multiple regression model is represented by y is equal to a plus b1 x1 plus b2 x2 plus b3 x3. It is going up to bn xn. Here the same x1, x2, x3, xn. These all are the future set. Okay, and whatever the b1, b2, bn, these are the slope, and whatever the a, it is the intercept or constant. Okay, right. So if you are going to represent the linear regression model in a two dimension, that we can say that we can able to represent as a straight line. If you are going to represent the linear regression model in the three dimension, we can able to represent that in a plane. If you are going to be represent the linear regression model in more than three dimension, that is here called as the hyperplane. Okay, so the same equation I have been given in the different representation only. Instead of I'm mentioning about the b, I have been mentioned beta 1, beta 2, beta b, and instead of I'm using a, I have represented here as the b0, but this x1, x1, x2, xb, these are the predictors or independent variable or x variable, or another name they have to give us the explanatory variable, right? Some of the places they have been mentioned it is a predictor, some of the places they may be using independent variables, some of the places they may be mentioning explanatory variables. Okay, and what about the beta 0, beta 1 and beta 2? These are the coefficients, right? These are the coefficient, right? And whatever the epsilon, it's a random error or noise, right? And whatever the y, it is the response, or it is the dependent variable, or it is a observation we are going to make it, or it may be a y variable, right? Right. So when we look at the linear regression, simply it shows the relationship between the dependent variable as well as the independent variable, right? If linear regression, it is just the plotting of relationship between the independent variable as well as the dependent variable y. One more thing, multivariate or multiple linear regression model, it is just a linear regression which is going to be carried out on the more than one number of independent variable. Okay, so that is the thing in the only thing in the multiple linear regression model. Right. So you may be having a question here as why we need a multiple linear regression. Okay, isn't it? So many of you, we may be having the doubt on that. So many of us, we have the question on that. Okay, so most of the real world problem will have more than two variables to predict the something. For example, if I want to predict a particular disease means, right? So doctor will ask about you to mention what all of the symptoms are there. Okay, based on the symptoms, number of symptoms only he or she is going to be decide about the this is a disease you are having. Okay, so the particular disease is going to be depends on so many number of symptoms. Okay, so that's a reason. That's most of the real world problem that we have more than two variable for predict something. So that's a reason we need a multiple linear regression model, right? So another name of the multiple linear regression model is the multivariate linear regression, right? And when we look at the implementation steps for linear regression model, which is always same as the simple linear regression model, what's the difference here is mainly for evaluation. Okay, so here we have to find out which factor has the highest impact on the predicted output. Okay, so this is the symptom you are having a more means based on it. What is the exact disease you are having it? Okay, right? So you have to find which factor is having the highest impact on the predicted output. How the different variables are related to each other. So that's a thing is very, very important when we go for using a multiple linear regression. Okay, right. So before we are going to be having a hands-on, first we should understand three main concepts here. One is the training and testing data creation. Another one is the mean absolute error. And third one is the root mean square error. Okay, right? So one is the training and testing, data creation, and mean absolute error as well as the root mean square error. First, we are going to look at the training and testing data creation. In order to evaluate the performance of the machine learning model, we have to divide the given data into two sets, okay, or two halves, right? Training set and also the testing set. Okay, mainly the training set is for used to train the model, and testing set is to used to evaluate the trained model. Okay, so most preferably we are having 100 data set there means if you choose 80% of data is for training set and 20% is for testing set, means we will train the model in a very good manner and evaluate the performance for model is going to become good. Okay, so first we have to decide how much amount of data set we are going to use for train the model and how much amount of data set we use for the testing part. Okay, that we have to be decided. And next we talk about the mean absolute error, right? Usually least square error we have discussed earlier in the previous session. Okay, with the help of that they have evaluate the simple linear regression model. Okay, here we are going to be using a mean absolute error. Okay, it is one of the way of comparing the prediction with actual values, right? Comparing the prediction values as well as the actual values. In order to comparing it, the mean absolute error is one of the way for that. So mean measured between the predicted and actual values here. It is the arithmetic average of the absolute error. Okay, so it is known as the scale dependent accuracy error. But we can't able to use this evaluation technique for make the comparison between series using a different scales. I will explain what is it later. Okay, so the mean absolute error is calculated by sum of absolute of prediction minus actual divided by the total prediction. That is the formula for mean absolute, calculating the mean absolute error for the model. And let me talk about the root mean square errors. Right, it is another one way of comparing the predicted value and actual values. Actually, it is the frequently used measure of the difference between the value predicted by the model and actual value. So generally, it represents the square root of the differences between the predicted value as well as the actual value. Okay, right. So normally, it is a measure of the accuracy to compare prediction error of the different model for a given data set and not between the different data set. Okay, if I want to compare the two different models, suppose I have tested one data set with the help of single linear regression model and tested the same data set for the with the help of the multiple linear data set, right? If I want to compare that two models, I can go for using this evaluation technique, that is a root mean square error, right? I can't able to test it for the same data set. Okay, same data model I am having it. I am going to be use it for the different data set, means it won't be working. So depending upon the application only, we have to choose the performance evaluation measures. So the last session also some of you asked about the whether F1 score we can able to use it here for evaluation purpose, right? According to my knowledge, as per my knowledge, I can say we can use the F1 score for the classification problem. If you go for the regression problem, root mean square error, mean absolute error, these are the performance metrics we can able to use it for correctly evaluate our model. Okay, and it is also a scale dependent measure only. So RMSE is equal to square root of sum of predictions minus actuals raised to 2 divided by the total prediction. This is the formula for the root mean square errors. Right. Let me talk about implementation of MLR. Okay. So if we go for using a linear regression model, your variable should be continuous in nature, not a categorical values. You can't able to take it. If your data set having somewhat categorical values, you can't able to apply the linear model for predicting something, right? At the bottom of our slide, we have on a graph is there. Okay, it shows the different events carried out in the different countries, like United States. 700 events was carried out, and Russia some 500 events was carried out. Okay, suppose you are having a data like that, we can't able to apply the linear regression model for predicting anything. So we have to convert this data set into continuous one. Okay, that is data set from your categorical data set into continuous one. For example, a data set would contain the occurrence of some event that shows that here. So your categorical variable must be converted into continuous variable. That should be hard to keep it in your mind whenever we are going to be implementing any regression problems. Right. So what are the ways to convert the categorical data into continuous data? Okay. Generally, the variables are two types. One is the dichotomous variable, another one is a nominal or ordinal variables. Okay. What is the dichotomous variable here? Normally, it exists only one of the two categories, right? Your data set may be having yes or no type values, or white or black, or some two value categories are there. Okay, for example, some of the data set you may be having, you have to represent the sex. So on that time, you may be mentioned male or female. Okay, so only two values are going to be repeated. Okay, so these are the dichotomous variable we can able to easily convert it. That is one of the categorical data. Okay, we had to convert that categorical data into the continuous data in a very easiest manner. We had to simply put label as 0 or 1. If your data is having yes value, means you have to convert it as a 0. Sorry, convert it as a 1. If it is a no value, means you have to convert it as a 0. Okay, and next is the nominal or ordinal variable. Right, it may be any number of categories. Okay, some of the order to the variables, or that the variable should have the different weightage. Okay, it can be converted into continuous value by assigning them numbers starting at 0 and running until the length of the categories. So many categories are there, means, right? Sometimes in your data set may be having a colors of cars, so it may be having so many categorical values that should be converted into some numerical values that is going to be starting from 0 to running until the length of the different categories. But the conversion of nominal or ordinal variable, categorical variable into continuous variable, that is a very challenging task. Okay, so that's the reason some of the ways are also there. One of the ways is the convert it into the numbers. Okay, so I already mentioned we converted them into the numerical values. So yes or no. In order to represent the yes, we have to give the 1. In order to represent the 1, in order to represent the no, we have to give the value as 0. Okay, so that is the way we have to convert it into the numerical value. And next is the combined level. What it is going to do, it is going to be avoid the redundant levels in the categorical values. Some of the data is going to be redundantly repeated, some colors, right? In that situation, instead of we are going to be repeating the data, we are going to be represent some way. That way is here called as the combined levels. And using frequency or response rate, combining the levels based on the business logic here. And last one, that is one of the most popular way to convert the categorical data into continuous data is the dummy coding or one-hot encoding techniques. What is the dummy coding? It is commonly used method mainly for converting the categorical input variable into the continuous input variable. See the example here. Some of the row of your data may be having colors as red or green, or it may be having a blue. Okay, in order to represent it, okay, how we can able to give the one-hot coding is each and every row you have to represent red, green, blue. Okay, suppose that particular data set is having the feature red, means you have to put one there in the particular row, and it does not have the green and blue color, means we have to put the 0 on the particular row. So this is the way we are going to be converting our. Sir, we have to convert it as a common data type. Otherwise, we can't able to. That's the reason I have been mentioned about the encoding techniques. Okay, suppose your data is the combination of number and words, means at that time you have to convert it as a some values you have to be put it. So here even color red, green, blue, that is a string only. Okay, we have to make it as a continuous value. Otherwise, we can't able to do the regression model here. Right. So next, already this thing also touched by the last session. ML. If we are going to implement any ML model, machine learning model, means first we have to. What are the steps here? Is first we have to prepare the data and then create the model. And after create the model, we have to train the model. Okay. Once we train the model, we have to evaluate the model. This is a normal or common steps. We have to be use it. Okay, and similarly, how to handle the unstructured data, right? So whatever may be the data, it may be the structured data or unstructured data. Okay, as a user, we have to decide what all are the data we need for predict something. Okay, first we have to identify it. Right, and also we have to convert that data into continuous values, not in a discrete values. Okay, then only we can able to implement that in a linear regression model. Right. So I would like to take in some data set. I thought so. From that discussion, I can able to understand what I said. Okay, so I'm going to be taking one of the data set oil and gas industry, which was created by the Michael Byers, professor from petroleum engineering professor from the University of Texas, where he has predicted production of gas per day based on the well index, well average porosity, and permeability, acoustic impedance, brittleness ratio, as well as the total organic carbon and virginite reflectance. Based on these 6 parameters or 6 features, that is well index, well average, porosity, permeability, acoustic impedance, and etc., he is going to predict how much gas they can able to produce or generate per day. That has to be measured in terms of MCFD. That is a 1,000 cubic feet per day. Okay, that is mega cubic feet per day, right? Okay, so that data set only we are going to be taken here for hands-on session. Okay, already I have said here nearly 6 features are there, which are going to be represented as a POR, PERM, AI, PITL, TOC, and VR. Okay, out of this, we have to identify what all are the features are more important to predict the production of gas. Okay, remaining all are the supporting features only, right? So POR is the one of the important feature, that is porosity of the well, as well as brittleness ratio is also the another one important feature for predicting the production of gas. Okay, right. So, sorry. So just I'm going to be implement the hands-on session. We will start and we will do the find out the gas production. Okay, similar to the previous session, I will share the code through the chat box. You can able to use that code and you can able to try to implement with me. Okay, I thought so. That is okay for you, right? Any one of you can able to chat it? Yes, thank you, sir. Thank you. So I will share the code. At the same time, I will explain also, right? All of you, first you should download the data set from this link. First, we have to download the data set directly from this link. It will be downloaded as a CSV file only. Okay. Then you can able to use it. I will open the Google-colab. Once you downloaded the data set as well as open the Google-colab, you can inform to me. We will continue. I'm waiting for that. Yes. Okay. Shall I proceed? I thought so. Now you can able to view my Google-colab. Right. Okay. So first we have to import the necessary packages like pandas, matplotlib, sklan, and numpy. Already you know what is the purpose we have been used this numpy, sklan, matplotlib, and pandas. Okay, even you know about it. I will explain. I will give small thing about the what is Panda. Mainly, the Panda is for handling your data in a very easiest way, right? And also, Matplotlib package is mainly for creating a graph in your data set, graphical data set, as well as sklan, where we have so many machine learning models already exist in the sklan packages, and numpy mainly for handling some mathematical way of processing in a Python data type. You can able to easily do it with the help of the numpy. Okay, these are the packages we need it. We have to just use that packages. I shared it in the chat box. You can also use it at the same time. Right. So after we have imported the all the packages we needed. Okay. And next we have to do your step is we have to prepare the data set. Okay, so in order to prepare the data set, already we have already downloaded the data set. We have to upload the data set into our Google-colab. Okay, the last sessions, Mr. K. Vignesh Ronan mentioned about we have to track the CSV file directly to your Google-colab. That is the one of the way we can able to do it. Another one way, with the help of this command, that is from Google-colab import file. Okay, just you are going to import the file from the Google-colab, and I'm going to be uploaded that file from my local drive. Okay, if I want to upload the file from my local drive means first I have to include the Google-colab package, right? From that I'm going to use the class name of the file. With the help of that files, I'm going to upload that file, and which is going to be represented by uploader, which is going to be stored in the object as a uploaded. So I shared that lines of coding also. Once you run this code, immediately it will ask you to upload your file, choose the file. Okay, so just you have to choose the file. Wherever you have downloaded the data set, okay, just choose the location of the data set you have stored it and open it. Okay, once it is going to become 100% done, your data set has been uploaded successfully. You can check it. On the left hand side drive is that, just we are going to check that means you will get the whether the file has uploaded or not. Now we can able to see the file has uploaded here. Okay, and sometimes it may be taken some time. What's the reason is due to your internet speed. Okay, right? In order to upload the file, it will take some time depending upon the size of the file as well as the internet speed. It may be different. Okay, right? I thought so. All of you completed up to this. Yes. Now we have uploaded the data set, right, from the local drive. Okay, and next, what's your duty is we have to read the data file. That is the next duty. How we can able to read it is with the help of the Panda package, right? We have created one of the object named as a PD. Okay, so with the help of this PD, we are going to read the CSV file. Those who are very familiar with the C programming, which is more or less equal to the open function. Okay, same as to here we have the in a Panda, we have the read CSV file is there. Okay, suppose your file is in a Excel format means, okay, instead of we are going to be using a read underscore CSV, we can use read underscore Excel. Okay, right. So now we have the format as the CSV file. So we are going to be using the function as read CSV. This PD is the object of that class Panda. Okay, and read CSV is the function. It's a built-in function which is inside the Panda class. Okay, so the main purpose of this read CSV is mainly for load the data set CSV in the format of CSV. Okay, right. I will copy that code and I will share it to you. And at the same time, I'm also show the result to you also. Yes, thank you, sir. Thank you. Okay. So now I just copy that. Right. So once we have given the df.head, it describes about the data set. Okay, there is no need to write this code. That is df.head. There is no need to, not necessary to write it. But if you want to, suppose if you don't know the structure of the data sets you are having means, on that time you can give this. Okay, and sometimes some of you may be directly using the some of the data set already in the internet. Directly you can able to load it. Okay, in such cases you can give df.head means we can know what all are the future sets are there. Each and every columns here represented as a futures. Okay, that is well as well as porous and as well as the permeability and acoustic impedance and brittleness ratio and total oxygen, organic carbons range, and vitinic reflectance, as well as the production of the gas. Suppose we are having a 12% of porousness and 2.92% of permeability, 2.80% of AA, 81% of 81.40% of brittleness, 1.16 of TOC, and 2.31 of VR means we will get the gas production is 4,165 MCF. That is the real world problem value they taken as a data set here. Similarly, they have carried out so many number of created the so many number of data value as a data set we have loaded here. Okay, right. So up to that step, I thought so all of you may be completed. Okay, right. Next we have to mention the futures, right? As I have already mentioned, one of the important feature of predicting the production of gas is the porosity, right? Porosity is the one of the important feature I have been already mentioned. And one more feature also very, very important here is the what? Brittleness. Okay, so that two things are the brittleness ratio. Two things are the very, very important feature for predicting the production of your gas. Okay, so here we have to mention what is our futures and what is our target value. So I will start from the simple linear regression model. Then only we can able to easily understand what is the purpose we go for the multiple linear regression model. Okay, so I am going to mention about the features. Feature as the porosity. I have given as a feature parameter as a list data type. Okay, here also the same. I did some mistake. Here also the list data type only. So just I am going to read the data set of porosity as the feature, one of the feature, and target value as the production of gas. So that two things I have been mentioned it first. Okay, right. So I share that. Right. At the same time, I will also do it in my Google-colab. So simply, so it will show some error. I thought so. So simply I have to put right. Next, what I have to do it here is next I want to do the pre-process. Okay, right. Most of the scikit-learn training function, right? It requires the reshape of future for the data set. Okay, so such as reshape of -1 comma length of futures. Okay, what is that case here is we have to import the data from Panda data frame. So we have to give the first argument is always -1. The reshape is the one of the function in the scikit-learn for reshaping your data set. One of the argument for the reshape is which type of data frame you are going to use it. Here you are using a Panda data frame. So that's the reason always you have to give the first argument as -1. Okay, and the second argument is how many number of future you are going to be use it for your training your model. Okay, here in order to I have stored the futures in the one of the list data type. Once I have found the length of that list means I can able to get how many number of features I am going to use it for training my model. So as we all know, currently I am using the feature as the porosity as the one of the independent variable. I have used it here. So the length is now become 1. Okay, so the pre-processing is also required when you make the prediction based on the fitted model. Yes, right. So now I'm in order to pre-process it, right? I have already stored my data frame, that is future, in the future as a list data type. So I had to convert that as a one of the data frame, pandas data frame. So df of future, if I am going to mention it, means it is going to be converted as a data frame. Then that values I had to be reshaped it. So dot values dot reshape of -1, that indicates it is a pandas data frame. Okay, and length of the features, that indicates how many number of features I am going to use it. So here it will return length of features, means it will return 1. Okay, and similarly target value is also I am going to be converted as a value. If I am going to be print that x dot shape and y dot shape means, right, it will return back. Just I share this code to you in the chat box. At the same time, yes sir, yes ma'am, I will do it. Right, so at the same time I will paste it here also. Right, so actually this data set contains 200 data, both the feature data set as well as the productivity of the gas they have created as a data set and the 200 data. So that will be returned back to us. Okay, right. Now we have pre-processed our data and print it, isn't it? Right? I thought so. All of you maybe completed up to this. Shall I wait for that? Or I can able to proceed it? Okay, sir. So I will continue. Right. So now what you have to do is you have to fit the linear model. Right. So since we have only one feature currently we have been taken. Okay. So the linear model we want to fit it as the following structure. Gas production is equal to beta 1 times of borosity plus some constant value beta 0. Okay. So that beta 1 is the regression coefficients and beta 0 is the y-intercept. Okay, so in order to evaluate it, we are going to be using a OLS, that is the ordinary least square method we have been used for evaluate that model. Okay, so I am going to be using in order to create the model, right? With the help of the sklan, I have used one packages, right? I will show what is it. So before that, I copy the code and send to you. Okay, right. So OLS is the ordinary least square. Okay, so this is the linear model. It is the one of the object for the class linear model sklan here. Okay, so it is the object for the class linear model in the sklan package. Okay, so I have created the object as the linear model here. I thought so. I posted. Sorry. Okay, right now just I compile run this means the model has been created and whatever the future data set I have given and what is the target value I have given, based on it my model has been trained. Okay, next. So I fitted the model. Okay, and next I want to identify the regression coefficient. What is my regression coefficient? Okay, so in a sklan we have the one of the function as the coef. Okay, model.coef. Okay, so that model.coef, actually coef is the function. Model, we have created the model as model equal to OLS.fit. So that variable you have to be used, and with dot coefficients, if you are going to be given COEF underscore means coefficient means it will give the regression coefficient to you. And similarly, if I want to know the y-intercept, okay, that is accessed with the help of the function intercept underscore. Okay, with the help of this two functions, COEF as well as intercept underscore function, I can able to get the linear regression coefficient as well as the y-intercept coefficient. See, I will share the code and at the same time, I will also do it here. So try to copy it in the two separate code editor. Okay, two separate code editor if you are going to be given means it will shown like this. Okay, once you are going to be using a model dot coefficients underscore means we will get the value as 287.78 and also the y-intercept value is we are going to be getting as here minus 2.94. Okay, so based on the result, okay, the gas production is in order to represent the linear model, gas production is equal to, that is my target. So gas production is equal to 287.78 amount of porosity minus some error values 2.94. Okay, that is the way I can able to represent the linear model for the problem I have taken here. Okay, right. Now we have to identify the accuracy, right? So in order to get the accuracy, we have to use the R square, right? Root mean square. We have to take and with the help of that only, I can able to identify how good was my model. Okay, so we can able to evaluate your model performance in a form of R square with model dot score. Okay, the score of is the one of the function that x is the actual value and y is the predicted value. I'm going to be pausing it means based on it, it will give the R score value to me, right? So that is the result. Based on that result, I can be able to identify how good was your model. So x is the future and y is the response variable we have used to fit the model, right? So just I'm going to be using a model dot score here. Score of capital X comma small y because I have represented like that. Okay, so just I'm going to be run this means. So it will show 0.7428. So what's the meaning of that as 74%, 74.28% only your model will give the output. Okay, right? So I want to train this model. Before I'm going to be train this model, I want to get the, I want to do somewhat future prediction. Okay, right? How I can able to do the future prediction, right? I have prepared the data set. Followed by the prepare the data set, I have created the model. After created the model, what I have done, based on the prepared data set, I am going to fit that data set into the model. Okay, after that, I want to evaluate it, right? Evaluation is also done. So it has to produce, the model has to produce 74%, 74.28% accuracy. Okay, right. So even it will give the 74.28%. We have to do some future prediction also, right? Let me see. In order to predict the gas production, when the porosity is going to become 15%, right? Whenever we are going to be taking the porosity is 15%, how much amount of gas will be produced? Okay, right? For that, what I have to do is first I have to convert that 15% as a numeric array variable. So for that I am using a NumPy. NP is the one of the object for the NumPy class. So np.array I'm going to use it means it will be converted as a 15. Okay. Next I'm going to reshape it. Usually whatever the things we have done previously, the same way I had to be do it. So once I have do and I'm going to be do the model prediction means. Okay. What will be the results? See the future prediction. will share the code to you. At the same time, I will do it in my notebook also, Google notebook also. So if you are going to be using a 15% of porosity means the gas production per day is 4,313 MCF per day. Okay, mega cubic feet per day. Okay, if you are going to be taking the 15% of porosity level means you will get 4,313 MCF per day. That is the future prediction I can able to do with my model with the accuracy level is only 74%. Okay, and suppose if I am going to improve this 74%, I will get the gas production value may be changed. Right, once I am going to improve the score value maybe 84 or 90% means the accuracy is going to be increased means automatically I can able to get the exact value of how much amount of gas production when 15% of porosity I have been used. Okay. Right. So according to the model, the gas production value is 4,313 MCF per day when porosity is going to become 15%. Okay. So MCF already I have mentioned it is the 1,000 cubic feet. Okay. Right. Now again I would like to improve 1 second. Right. Only one porosity we have been taken. For that we have calculated the 15% only. Suppose I want to calculate the porosity value is 14% as well as 18% of porosity I am going to be taken means what may be the gas production I will be getting. Okay, in this way I want to be predicted means, right? So again I am going to create the list with the 14,18 that has to be converted as a numeric array. Okay, that is I am going to be taken as X prediction, right? And do the reshaping it, right? And then I am going to be given it for the prediction of my model means I will get some gas production value. Okay, right. So see the code for that. I will share the code and at the same time I will do it in the Google-colab also. So what indentation will be getting. Right. So whenever you are going to be using the porosity is 14%, okay, right? We will get the gas production as 4,025 MCF. If you are going to be using a 18%, right, I will get the gas production value as 5177. 2 minutes, sir, please. Yes, I thought so. We have completed. Yes, up to these steps we have completed. Yes. Shall I proceed to the next? Shall I proceed to the next? Yes. Right. So now I want to visualize my data in the graph. Okay. So how we can able to visualize it? Right? In order to reasonable real life value of the rod porosity range, which is going to be ranging from 0 to 40%, I have been taken, and 200 data sets I have been taken for that 0 to 40 range. Okay, and that is given as a future here, right? So I'm going to be taking the link space of that 0 to 40, right? Okay, so just I'm going to be taking this. In order to convert it to in a graphical way, first I want to be taken as a linear specific space in the porosity, the value from 0 to 40. In that range, I'm going to be taken the 200 ranges, 200 data set that I had to be converted as a future here. Okay, so just I'm going to be use it as a future here. Next, what I had to do it as. Next, I want to plot the values. Okay, how I can able to plot the values with the help of the matplotlib. All right, so that already discussed in the previous session as well as the second session of the first day. Right, so I had to use the plot style as the default as well as the ggplot. Ggplot is the one of the predefined graphical platform. We can able to use it in the both even MATLAB as well as the R programming also we can able to use this. The same we have to use it in our Python environment. And also I am going to fix the axis plat subplat plat. I have called the subplat function on that where I had to fix the picture size in my Google sheet, Google-colab sheet. My height of the figure size is 7 and 3.5 is my width. Okay, and then I have been created the label as the regression model that I had to be plotted in my plotted area. And then in order to mention the sample data, I'm going to be using a scatter plot. So ax dot scatter, where I have been mentioned the x is my independent variable and y is my predicted variable. And each color I have been given some values, and face color I have been given some gray values, right? And label I have been given for that as the sample data here, right? And similarly in the y label, I have been mentioned about the gas production per day. For that I have been set the font size is equal to 14 with the help of the function set underscore y label. And similarly, I can able to set the x label name as the porosity percentage. The font size I have been used the same, and you can able to give the legend for the all the face color as well as the font size. For that I have been given that, and then all the text sizes, coefficients are that I have been set it in the axis. Okay, once I have this amount of lines of codes mainly for draw your graph. That's all. Nothing else is there. Just I share the code for that. Then you can able to at the same time, I will work it in my Google-colab environment also. If it shows somewhere else, it shows the error. That is nothing. The identification problem is there whenever we are going to be copying it. So just simply do it. So once we have finished, we will get the output like this. So just we will take the porosity as the independent variable. Based on the porosity percentage increased, what is the gas production? Based on it, what is my linear model? Best fit value I will be getting with the help of the linear model is y is equal to 287.7 x1. That is x1 is here porosity minus 2.94 means I will get the best fit line. Best fit line once we get it means the root mean square error is going to become reduced. So I will get the accuracy level is 74 point something. I got it previously. Okay, up to this, understand? Shall I proceed to next? Up to this, you have completed. Shall I proceed to the next? Getting error with the, yes. Which line, sir? The same only, whatever the things I have copied to you, the same only I have been used it here. I thought so in the second line, whenever you are going to copy it, I leave one indentation, Python. You had to give the indentation correctly, otherwise it will show the error. Even I'm also getting the same. So just do it backspace, and you can able to run it, means you can able to get the answer. Last line. Kindly check close brackets are you have copied correctly and etc. Kindly check the close brackets are done properly. Like Python, put line 10. Yes, I will share once again. Oh, ABS code is missing. Shall I send the last two lines? I'll do it in separately, then you can get it. Yes, you can able to upload it, sir. Finish. Shall I proceed to next? Okay. Right. So now, up to now, we have taken a single feature, that is a porosity only we have taken, and we, based on it, we predict something. Okay. Now, we are going to implement the MLR implementation, that is multiple linear regression implementation. Okay. Slightly do small changes in the MLR implementation. Okay. So future, I'm going to be adding some more features also I have been added. That is independent variable. Instead of porosity alone, I'm going to be taken porosity. In addition to the porosity, I'm taken the brittleness value, perm value, and TOC value. I'm going to be taken based on the combination of these four. How much amount of production of gas I can able to generate it. That I'm going to be taken as a target. Okay, right. So again, I will share the small level of codings to you. Similar to the previous case, just I'm going to change the features, do it as the new code, and I'm going to be given the new code is. So here again, somewhat indentation is there, space is there, just leave that space and run it. Here I did one mistake is for regarding the product, I want to give the give it in the list data type. And one more thing, whenever you are going to be copying your, sometimes you are going to be copying some string from the Word to Google-colab or whatever the other platform for Python execution you are going to be done. On that time, it will be considered as a Unicode. That symbol is going to be taken as a Unicode. So just you are going to be once again type the single code representation here, then your problem will be resolved. Okay, your problem has been resolved. So afterwards, after this feature have been mentioned, what I have been done next, I want to be pre-process my data set. So again, you have to copy these lines. Already we have that line. So just copy that cell. Okay, previously we have used only the porosity. After that porosity, we have to be pre-process our data as in the data frame. Okay, so copy that line and put it in the last. Just click on the whatever the line you have typed last, press the code and copy cell. Sorry, paste cell. Control C, Control V here, and run this. Now also you are going to be taken the what? The first is the X, right? 200 data sets are there. How many features that we have been taken? 4 feature set we have been taken. That only it's shown as the X dot shape. And similarly, target. What's the target value? Single target value. So 200 data sets. The data number of data sets, data value in the data set is the 200. Only one target. Okay, right. Now I thought so. You got it. This next, you had to train the model. After this, you had to create the model once again. There is no need to create it. At least you have to fit the model once again. Okay. So here, sorry, not get copied. Next line is we have to fit the model. I will share. Do you want to share the code, or you have copied from your already existing one? This is the multiple linear regression I am going to be doing. So just I will share it in the chat box. No problem. Yes, if you copied means no problem. Otherwise, I will share the code. So sorry, whatever the things I have chatted last, futures and target, that you have to be put it first. Afterwards, you have to reshape your data set. Okay, now I have created the model with multiple features like porosity, brittle, perm, and TOC. Okay, so I have created the model. What's the next step I want to do it? I want to find out the model coefficients. Okay, I just give the model coefficient. So I get the model coefficient is 244.6 is the porosity value, 31.58 is the brittleness ratio, and 86.87 is the permutability. Sorry, permeability. Okay, and 86.87 is the what? TOC. That is the way we have to be taken. Okay, and next I want to find out the y-intercept value. So how I can able to get the y-intercept value? With the help of the model.intercept. Sorry. So click here and put the code next means you will get it. So now we have to get the minus 1575 is your intercept. Okay, right. So now you've got some values. Okay, right. What's the next thing you want to be following here? So from that, right, based on the result, right, result of fit, we obtain the linear regression modulus. If I want to predict some gas production, means if you are going to be combining the porosity value as 244.6, and 31.6 times of brittleness, and 86.9 as the 9 times of permeability, 325.2 times of TOC, that is a total organic carbon, and which all are going to be subtracted by the what? B value, intercept, y-intercept value is the 1616. In our case, you may be getting some other values also. Here I am getting a 1575. Whenever I run previously, whenever I prepare the PPT, at that time I got the value as the 1000 something. Okay, so some small different value I got it. Okay, so y-intercept as well as model coefficients also I got it. And next, I want to identify the what is my model score. Okay, that is accuracy, that is R score value, what is it? So in order to do that, just I am going to be given model dot score of that x value comma y. That is actual value divided by predicted value. Actually, x is the future value and y is the target value. Based on it, what is my accuracy rate? I got it 95.16. Okay, 95.16. And previously, if I am using a single feature, what is my R square? I got it 74.28. Okay, that's the reason only I started from the linear regression implementation. From that, I introduced the multiple linear regression, how we have to change it in the code, and what is the benefit we will be getting. Whenever you are going to be adding more features, automatically you will get the good accuracy rate. Okay, right. So now I got the accuracy rate as that is R square value as the 95.16. Right? Okay, next. So based on it, we are going to future prediction. How we are going to predict the future? Suppose if I am going to be taken the 12% of porosity, 81% of brittleness, and 2.31% of VR, and 2.8 kilogram per meter square is the A value means. What may be the gas production that I want to be predicted? Okay, so if I want to predict like that means what I have to do it as porosity already given as a first value, and brittleness I have given as a second value in the feature data set, and 2.31 as the VR value, 2.8 as the A value. I had to make it as a num array. Okay, numpy array I have been created here and converted. I had to do somewhat reshape it. After I reshape it, I had to predict it. Now, can we check what's the value I will be getting here as? I will share the codes to you, then you can able to get the value. Right. Okay, so I will add the code here. Sorry, somewhere else I misinterpretedly press my mouse. Okay, so now I'm going to be copy that. Now I'm going to predict the value of X prediction means. Okay, what may be the answer I will be getting? Right. Suppose my porosity value of the well is 12%, right? And in that bore, permeability value is 81%, and A value is 21%, 2.31%, and 2.8% of TOC value I'm having it means. In that well, I can able to predict this much amount of gas I can able to predict. I can able to produce it. Nearly 5,029 MCF amount of gas I can able to produce when 12% of porosity, 81% of permeability, and 2.31% of brittleness, and 2.8% of TOC. Understand? Right. Right. So now again, I'm going to make it some more complex. So only I'm going to be taken the 12%, 81%, 2.31%, 2.81%. Again, I try to get some more combination of porosity and brittle and VR means. What may be the result? Okay, right? At the same time, I want to get the result. Suppose porosity value is 12% and brittleness value is 81%. Just a minute, please. Okay, sorry for the interruption. Right. So I am going to be taking the two combination of that porosity, brittleness value, and VR. How much I can able to get the production of gas. Right. Let me see that. Right. I will share the same coding to you. Nothing. Just I am going to be taken as a different list value here. This is the first set of list value. That is the porosity 12%, brittle 81%, 2.31% of VR, and etc. Right, and similarly, this is the second set of value for prediction that I have been combined as a prediction here, and just I am going to be share to you. Then you will get I can able to do it. I will do it in my Google sheet also. Right. Suppose if I am adding, the combination is like this: 12%, 81%, 2.31% mean. I may be getting the production of gas is 5,229 MCF. Suppose if I am going to be adding the combination is like this, I will get the gas production is 4,531 MCF. Okay, right. So this is the way I can able to do the what prediction here with the help of the MLR, right? If you are willing, I will show how we can able to visualize in the 3D graph also. Otherwise, we will close the session. We will share the feedback. If you are ready, I will continue. Yes. Okay, ma'am. Ma'am, which one you got the error, ma'am? Bharati, ma'am. Others, can you able to do it? Any error you got it? Anyway, I will share the. Okay, ma'am, I will check it. I will share the code to you anyway. Right. Today we will create the Google Classroom. On that we will put all the PPTs and recorded videos and what all the coding session we have done, that also we have put it on the Google Classroom. Okay. Tomorrow morning I will share the Google Classroom code, Google Classroom code also. Okay. Right. Okay. So we will continue with that. So now, in order to do it in the 3D visualization, X, Y, Z only we have to be taken. So for that, I am going to be taken the two future value as the value for the independent variable, and we have to predict the production. So for that, I will share the code and just I will work on it. Then you can able to get the answer. Okay, so nothing. I have created the data frame. Whatever the code I share to you. Just I am going to mention the features. Instead of feature, I am using the variable here as the capital X. Instead of target, I am using the variable as Y here. Right. Now, I want to prepare the model data point for the Visualization purpose, for the visualization, preparing the visualization purpose, I go for using a prepare the model, data model. Okay, so for that x:0 means x:0 means automatically it is going to be taken the borousness, and y of x of colon 1 means it will be taken the brittle. So that two I have been separated as a two different x and y point. In the z I am going to be show it in the target value. Show the target value. Okay, so just I am going to share that also. So just run both of them. I also run on it. Okay, just I will write the code here also, then you can be able to get it. And then features only I have been mentioned, and then prepare the code for prepare the model of data for that. Now I have to take in the range of porosity value as well as the range of brittleness values. Okay, for that I am using the numpy function as the linspaces, where I am going to be taking the range of porosity values from starting from 6 to 24 up to 30 values. I am going to be taken in that range. 30 value I have been taken as a porosity value that I have been used as the X prediction. And similarly, brittleness value I am going to be taken from 0 to 100. That range is from 0 to 100 percentage. Brittleness percentage I have been taken from 0% to 100%. That's also I am going to be taken as a 30 value. So whenever you are going to be choosing the preparing the model data for visualization, the both value should be, number of values should be same. So for that, the porosity range of value as well as the brittleness range of value, I am going to be choosing the 30. Okay, and now I'm going to create the mesh grid with the help of that X prediction and Y prediction. Then only I can able to go for the flattening my data. For that, I'm going to do that. So in that place, what I have to do it is X prediction as well as Y prediction value, I'm going to be flattening. I'm going to be done in that already. Vignesh Ravanan already explained about what is flattening on the last session. So just I done the flattening here. That make it as a true here. Flattening I had to make it as a true here. So I share this code also. Wherever I put the hash symbol, that is the command line. So it won't be executed. I thought so you aware about it. Just I share it to you. And I put it in the so now I have prepared the data for prepare the data for the visualization purpose, right? Afterwards, I want to create I want to train the model, create and train the model, and the predicted model I have been stored it in the predicted value I have been stored it in the predict. So this line is for creating the model, and whatever the data feature I have been created based on the data feature and target value I have fit the model. Afterwards, I'm going to predict the model. That value is going to be stored in the predicted. That only I have done in these 3 lines. So just copy it to you. So the same thing I have to done in here also. Right. So once it's done, what's the next step we have to do it as? We have to evaluate our model. So we have to generate the R2 value. So in order to generate the R2 value, simply we are going to mention model.score of x comma y. So instead of that, whatever the value I got it, that I try to store it in the another one variable name I have given as the R2 here. Just I'm going to store it in the R2. Once you have stored it in the R2, it won't be give the results to you. If I want to know the result of what R2 means, I can able to give print of R2. Once I have given like that, I will get the value. So compared to previously we have used the 4 independent variable or 4 feature we have been taken. Based on it, we have predict the gas production. Okay, here in this session, we have taken only 2 features. With the help of that 2 features, we try to predict how much amount of gas predicted. So that model only give the 93.30% of accuracy. Okay, right? So there is no need to print it. So simply store that value in the R2. Right. Next, I am going to be plot the values. So plot using a default plot only. I'm going to use it, and the picture size I have been set it as here 12,4. Right, and here subplot I had to create the 3 subplots. Okay, axis 1, axis 2, and axis 3. And when we differently change the axis value, first time I show the porosity in the x value and target in the z value, and one more key thing, that is the brittleness in the y axis. Afterwards I'm going to change it, and afterwards I change the x and y axis value. For that I have been given this 3. Okay, so it will show the different view of the data set and predicted value, actual value we will be getting. For that we have been written this. Okay, so that 3 axis I have been created as a list that I had to be stored in the one variable, represented by the one variable. So for ax in the axis, I'm going to be taken one by one of the each and every axis parameter. Okay, and stored it in the ax. And next I'm going to be plot the values. Okay, so first time this is the normal line value, it is going to be plotted here. And the second axis I'm going to be taking the scatter plot, that is sample data set, it is going to be shown it there. And x label initial time porosity, y label brittleness, and z label I have been given as the gas production, right? And also I have been given the number of bits to show the accurately show your graph. For that we have been given the different number of bits, and finally we have to transform the view of the each and every axis by elevation, different elevation. So we will get the 3D dimension of our graph. Just I copy the code and send to you. Carefully copy it and put it in your Google-colab. So now I run it means I will get the graph like that. So porosity, first time the porosity in the x-axis, and brittleness in the y-axis, and gas prediction in the z-axis I have been taken, and I show the different way to represent the data. That's all. Different view of representation. That's all. Okay. So this is the way I can able to visualize the whatever the data set I'm having it. Here the R-square value is 93. So based on it, I got the result like that. Okay. Okay, sir. I will 1 second. I will share it, sir. Last 2 lines are last lines. Okay. Share it. So that's all about the today's session. Any doubts or any queries or any feedback, you can able to share it with us. I will share the feedback link also. Right, participants are kindly requested to fill the feedback link. That only we have considered as a utterance. And Thank you. Thank you, ma'am. Thank you, sir. Sorry. Thank you, sir. For the ma'am. Ma'am, you have copied the whole code, ma'am. Axis set Y label, you want to share it, right? Okay, I will share. Axis set. Sure, sir. I will share all the PPTs, all the links. I'm collected from all the resource persons, and I will within today evening or tomorrow morning I will do it put it in the Google Classroom, and you can able to take it, sir. So tomorrow's session, as usual, sir, due to some official reason only today we preponed the session. Sorry for the inconvenience. Sir, ma'am, tomorrow morning I will share the Google Classroom link as well as the Google Classroom code to you. No problem. Or today evening I will put it on the group, WhatsApp group. Participants, kindly put it on the, kindly fill your feedback. Thank you, ma'am. Thank you. Thank you, Subhashini, ma'am. Ma'am, I thought so the R2 you did not mention, I thought so. Before you are going to start the PLT style dot use of default line, you have to type this code. That is model score, you have to store it in the R2. Sure, sir, we will share the coding as well as recording video as well as PPT, sir. So finally, these all are my references. I made it. I prepared from the net only. Heartbeat.first and towards datascience.com, escapeabuse.com, financetrain.com, aegis4048 github.io. So these are the area I have. These are the references I have made it. If you read the financetraining.com, you can able to get the financetrain.com website. You can able to get the very good case studies. With the help of that, you can able to study a lot. Finance train as well as stack abuse and etc. Okay. Thank you to all. Thank you, ma'am. Thank you to all the participants. Once you have filled the feedback, you can leave. I will share the PPT, sir. No problem. Thank you, Kannan, sir. Thank you, sir. Thank you to all. Once you filled the feedback, you can leave, sir, please. Sir, I will send the PPT to you, sir. Surely I will put it on the Google Classroom.